recording it. Okay, so what I am trying to say is, okay, we'll write a small, just copy paste this. I will remove all these things.
That name equal to main. What is that? It's a.
Okay, so yeah, I'll tell you that, yes.
Okay.
These two will give you. I'll ignore this. So this one, right? I can write this. See, a lambda basically anonymous functions. Okay, so I can remove this code. Okay. I can remove.
Okay. I mean, no function with.
Yeah. So exponent. Okay, I can write exponent function. And return of
n into n.
N into n. Okay, so map transformation basically whatever function you applied. So basically the each element will be sent to that function, right?
Yes.
So map or transformation, it actually does that iteration, kind of iterating your elements in the RDD. So either you can actually put your function, the anonymous function, in this way, or you can write like this also. There's no harm in that. It's going to give you the same result. If I run this, it's giving the same. Just finding the exponent, okay? So here you just same thing. We just do that implementation. We do it here itself. That's why we call it as anonymous. So anonymous function is applied through this lambda keyword.
Yeah, that I got it.
Okay, so this one is name equal to main. So generally, when you write a Python, the Python program, what happens is the Python program itself a module. Okay, so there is a module and a package concept. Probably we have not discussed it. Module is Python one Python program is itself module. So if I I wrote a function called upper and exponent here, right? I can use this in another program. Okay, so I can just go and create one more program called demo one. Okay, I can import this. Like how we are importing the already the built-in packages or the packages from PySpark, we can import our package as well, right? So basically, you need to give the path of your package. So this program demo is exists in the same level where demo one is there. I can just go and import my demo. From demo, import start.
I can import exponent also, right?
Sorry, I think these two are in different places.
The exponent function can be imported also, right?
Yeah, correct. Just a minute, I just kept it in. I'll keep this. Yeah, so I can just call that function print of exponent is pass to 4. Okay, so this is module, right? And so when you run this program, okay. So if you run this program directly, okay. So you will actually when you run this program directly, the name is going to be main. Okay, there is a name which actually use. Suppose if your name will be main. If you're running from this code, actually we are using it in a other program, right? So this part of code will not run because we are not. This code, the idea is this code will be run only if you are running this program directly. You cannot run this code from other program. That's a very straightforward answer. This part of code will be run only if you run this program directly. You cannot run this program from other module or other program. Generally, the code which you want to, this code mostly used for kind of the code snippets which is used for testing your functions written in this program. Mostly it will be done in this. So this area is more of doing a small test for the code which is written here.
So can you go to the group by this group by function and will just relate to lambda?
Yeah, I'll go there.
Group by transformation. So normally whatever things we are doing by ETL tool, we can achieve by
group by key.
Right? Yeah, group by key.
Yeah. What do you want?
No. I just want to relate to this map and reduce.
Okay.
So the first line number 30, it is iterating each and every element, and it is.
Yeah. Here iterating each element. So our input is basically just
list.
RDD of just strings, right? A list of strings, right? So we want to get a key value pair because the group by key transformation, if you want to use, you should have RDD of key value pairs.
So what that line number 31, we are telling that E is input to the list, right? It basically is a list.
No, this is a tuple key value pair.
Oh, oh,
So
okay.
okay, I can run the I can run this. I can change this code as get EV. Sorry, KV. I get the E element. I just return as
Oh, full of E and
yeah E command, and I'll
oh,
just
okay.
call.
Oh, basically it will give 1 1 1 1 all.
Yeah, yeah, yes.
Okay, clear. So on top of this one, I will reduce your group by one.
Oh, sorry.
I mean, on top of this result, our group by key will happen, right?
Yes. So you this result, if you just
Print.
print here.
So we'll get each value one. I mean, each key basically one will be added after this. Right?
Yes, correct. That's what I just put it here.
Okay.
Each key will have 1 1 1 1 like this.
Oh, okay, good. So after that, okay. So line number 45, 42. So
Yeah,
you are giving
42. So we just this doesn't take any arguments. We just it is going to give you the uh, key, and it is going to group the key and give the respective grouped values. So
okay.
this this is going to give, if I just do this only this, if I write only this code, this line of code,
Okay. Okay.
if I write only this line of code, which is going to give me the result in this format.
Uh,
So there is a 3 distinct key. So the first key and its grouped values, because 3 is only
okay.
one time occurring like
Mm.
this. And finally,
So,
now you take this, apply map transformation, and sum up these grouped values.
okay. Okay. Okay, sir. Thanks.
All right.
Yeah.
Okay, fine. So join we saw. Join is it's almost. So join just gives the value, the joined value of two data set, two RDDs. So in this RDD, if you look at here, it's just mostly order and order header and details. So order header you will have like order ID and the order date. And order details basically you will have that mostly. So one order might have one or more uh, product being purchased. So if you see check here, so order one we have only one item is purchased. In order two we have a two item purchase, and we don't have actually order any product which is purchased in the order three here. So when you combine, when you join these two, so we are going to, it's mostly the inner join. When you just do join, it is basically inner join. So whichever is matching key is going to give it the result. So basically we just get joined values of these two key value pairs. Key 1 and 2. 3 and 4 will not come because it's not matching. And once you have a joined key value pairs, then it's up to you to do the what kind of aggregation you want to perform. So this will give you just a joined uh, uh, key value pairs, and then you need to do the respective uh, aggregates. You iterate each element and then access the things. So see if you just see here. So here, so this joint RDD as key and respective values from the uh, data set, the first and second. So it just gives the key and value as the order date, and order quantity. Now it's up to you to just sum up these values.
Okay. If there is multiple, it will be multiple or how?
Yeah. So basically, here you see here order one. And order two, it has two key,
Oh, okay. Yeah. Order has two
occurrence
values.
there. Now again,
Yeah.
you need to apply the uh, uh, either
Our
group by key
aggregation.
or reduce by key.
Yeah. Okay.
So we are applying a reduce by key.
Sorry, I have a quick question.
Yeah.
Do we always join on the key?
Yeah, mostly generally it is key only. Yeah.
Okay.
If you, yeah, mostly I think, at least to my knowledge, even when you go to join in our in traditional SQL join also, it's more of performing on a particular based on particular column, right? So
Here, where we are telling it will use first column, I mean the key in the join condition.
because it's, sorry, what did you ask?
No. In SQL join, we have to tell, okay, use this key. Like particularly, okay, employee number or department.
Yeah, so that we will do when you work on the data frame, because here it's not a table representation, right? It just
Okay.
you have the maximum you have RDD of single value or RDD of key value base.
Okay. So first value will be considered as key. I mean first.
Yeah.
Okay.
So basically, because we are actually the join operation is performed on the key value base, RDD of key value base. If you see here, this is my RDD. This is one of my RDD, which is having a tuple, which is key value base, right?
Yeah.
Okay, so yeah, so that's it. Now there is other few transformations. Okay, co-product is co-group is a more co-group is basically it is also join. Uh, thing is, it is going to do the uh, grouping with respect to individual RDDs. Say example, I have RDD which has a key value, like a key is, you think one and values like this. Okay, we have a keys 1, 2, 3 here, and there is another data set which is having again keys 1, 2, 3. Now, when you apply a co-group between these two RDDs, what it is going to give? It is going to anyway give the similar matching keys, okay, like we do on a join, and also it is going to group the within RDD. It is going to give you the group. Okay, so it is going to give you. If you look at this, you have in this we have distinct keys only, but in this data set we have uh, key one is repeating twice, and key two is repeating twice. So it is going to group these two within RDD. Okay, so if you let me run this, I'm show you. see. Okay, so all the keys are grouped. If you look at the grouped values, okay, this is the distinct keys 1, 2, 1, 2, 4, 4, 3. I think 3 and 4, right? There are 4 keys only, 1 and 2 and 3 and 4. And if you see the grouped values are 2.5 from the first data set, and you see the grouped values in a list from the data set 2. Okay, so either you can go and do the sum up at a global level, or if you want to find out the sum on individual data set level also, you can do. It's up to based on your requirement, you can do. If I do global level, all the values are 10 only. Okay, so but if you want to do at the data set level, so for the first data set I will get 2.5, and second data set I will get I think 7.5. Okay, that is a co-group. And then the Cartesian, I think Cartesian basically repeats for each key. There will be a for each, basically the individual value. There will be a combination of it will take one element and it generates the each element each like pair for the uh, another elements in the another RDD. Okay, for 1 again 1, 4, 5, 6. I think it's a Cartesian product. I think everybody knows. Right. With the one element, there will be a combination of other elements in the other data set. Okay, so for say for 1, it will take 1 and 1, 1, 4, 1, 5, 1, 6, 1, 7, like that. And it takes again the second element, it generates the key value first for the like this. I think a Cartesian product, I think I don't tell.
Yeah.
Okay, so I think it's fine, right? Cartesian product is fine. That's basically. I think everybody knows Cartesian, right? Cartesian product.
Right. It will aim into a number of elements, right? Each element from first it will join with all other elements.
Yeah, correct. Similar, same thing here. And there is one more transformation which you want to call the external script called the pipe transformation. Okay, so you can call the, say example, if you have a cell script, if you want to iterate each element in RDD and pass it to the script and get the result out of it. Okay, so I have a RDD of string elements. Who are you? And what I'm going to do is I intend a cell script just to change the case. Okay, so I'm just I'll just making in the uppercase, taking each line. Okay, so and making into uppercase, and then the result will be in the final the result RDD. Okay. So what are the script it supports? It supports, I think, Perl and the shell script or bash script. Any other program, I think it mentioned here bash and Perl and bash script. Any other type of script, I'm not sure. These two are mentioned here. Okay, so if you run this, validation. Actually, it's print also it will come because it will actually take the std out values from the script or whatever the echo value from the script, the RDD will get it. So this is the input passed, and we call the script and call the script to change each element to uppercase. This for simplicity, we just kept it this shell script. You can do whatever the script based on your logic requirement. You can change the script logic and you can call it. The idea is how to call the shell script from the PySpark to perform a RDD transformation. Okay. We just actually calling this shell script. So each element is passed to the shell script and the value, and it's getting the return value. Okay, so if you look at the action operation, we almost seen some of the actions already. So like I think reduce we will see. We saw collect, count, first, and take and all. And there is others the action operation like save as text file. Okay, so if you have a content, okay, so we have this. If you want to save this as a text file, and give the path. So just say pipe RDD .txt. Okay, so your content will be written in this one. So basically it is written into two different files. So because we have two partitions, so it is written into two different files in your disk. This is save as text file is the actions. So it is writing your result of that is the values. The output from your RDD is written to the file. So whenever you want to write your content of your RDD to the file, you can use save as text file.
This is a Hadoop file, right? SDFS?
Right now it is written in a local. You can write it in SDFS also. Because I file path, I did not give any path, so it is written into local. So if you give the STFS path, it will go on right in STFS.
Oh, okay. So how can I write it one file? Suppose I don't want.
Okay, so yeah, so there is a transformation called coalesce. Okay, so actually okay, so we'll do that. What you need to do is, this is the RDD, right? COALES, coalesce transformation. So you just use this ESC. So coalesce is the transformation which actually try to reduce the number of partitions from the large number to smaller number. So basically, if you have a partition of, see, since this RDD has two partitions, that's why you get a file with the two files with the content inside that. So if you make it as a single partition, right, before writing into SDFS or local, make it as file as of one. So what is going to happen? It is going to combine these two partitions and give the output in one. I just delete this and I run okay. I store this. Coalesce is to reduce the or decrease the number of partition in your RDD. So you have only one partition. Okay, and there is one more transformation called repartitions. Okay, this is also one of the very useful transformation. So repartition will help you to increase the number of partition as well as the decreasing the number of partitions. Okay. So example, now you have one partition. So example, I want to make this as 3 partitions. I'll just say 3 partitions. Let me delete this. So you see there is a 3 partitions. So basically, it created 3 partition, but did not put the values in other partitions. Okay, but it created a 3 partitions. Okay, so generally, when you want to reduce the number of partitions, you should use a coalesce, and because coalesce is again it's very similar to the group by key and reduce by key. Coalesce will try to reduce the data shuffling, and partition does actually the data shuffling. And coalesce will not do the like it will not helpful to increase the number of partitions. It's always good for reducing, or it does only for the minimizing the or reducing the number of partitions. Any doubt? So I think this will give you the fair idea about RDD transformation and actions. Next we will start a data frame, which is one of the very important concept in Spark, being a PySpark or Spark with Scala. Any questions or doubt?
No, very clear, good.
No questions. Great.
All right. So I will upload this today's recorded as well as the yesterday's recording. Then probably you can practice these actually examples, and let me know if you have any doubts. Okay, friends, we'll sync up tomorrow morning.
Yep.
Yeah. Thank you so much. Bye.